Okay guys, let's keep going. Well, welcome back and good morning. Now, this is funny but true. This Axelson lathe can make you $100. This Harley Davidson crankshaft will cost you $100. Looking at it at any direction. So I got some I picked up a few ideas from comments and feedback. You might find kind of interesting, and and I'm going to add into it the dreaded core shift. So let's look at core shift right off. Okay, I'll get set up. So at the Harley Davidson factory, obviously they had engineers design this stuff. And then they had machinists prototype it out to the engineer's specifications. And then they begin testing and they go, yeah, this is good. Okay, we're going to roll with it. Then we get into manufacturing. And that's where we come in as millwrights, okay? So I'm going to talk about core shift, and that's in the castings. And it's obvious if you look at it, you know, and you've seen it, but maybe you don't understand it. And here's a good example right here. Now, they didn't engineer the port here to be offset like that, ready to break off, you know. So this is an old design, and they got rid of it with panheads. And went with something even funkier with a shovel head. So you can see how thick it is here, how thin it is here. And that has an effect on the other side, on the intake, where, you know, it's got quite a step here. It's not quite as aligned, and it's got a step here, and it drops down up here. So when they cast this, the core that they use to do these ports, you know, so they didn't fill up full of metal. However they do it, I'm not a casting expert by any means. Played around with it at the community college. We had a speedy melt, and I forget what we did, melting some aluminum. But just, you know, kind of touching on it. So this is a flathead engine too, and the problem might not be as bad with this old style engine like that, where the valves are in the cylinder. Okay, so the later engines have the valves in the head, overhead valve. You know, imagine the technology for that. So it's even worse. A little bit of shift in the castings on overhead valves, it has a worse effect. And they had core shift pretty well under control through the panhead years, and it's like the last of any of the engine series were generally the best ones. And well, they just kept tweaking it and working on it and stuff. And so enter the shovel head. And then a lot of troubling times and bad economy and all that. And I want to remind you that when I was into this in the 70s and got certified in 1981, Harley Davidsons were not popular. There was no craze. There was no retail financing like they have now. You couldn't go, if you worked at McDonald's, pay from what I understand, you can at one point, or they were talking about it, up to 9 years financing on the thing. Well, Instead of $3,000, in the late 70s and 80s, you could pick up a Sportster or something, entry level now is what, 20, 30? I don't know. I don't keep track of it anyway. But so when the manufacturing happened, things happened like the core shift, and it was bad through the shovel head years. Just it could be horrific and bad in the early Evos. And if you try to hot rod something like that, that's where things get, the most expensive horsepower is a hot cam. Stick some hot cam in this thing that's got core shift, uneven flow, bunch of other problems, and you're just going to have havoc. Now, this engine, these cylinders are honed, was built by a shop. And it's just a horrific job. It was terrible, and it never was run. Got a little flash of rust in there over the years of owning this thing. It was never run, and when the guy had this done, or he bought it, I don't know, I can't remember. Put oil in the transmission, it started leaking out. Then he brought it to me, and we started finding these problems. Okay. Now, one of the bad things that this guy overlooked was, where'd that go? Somewhere here. I'll stand up and look for it. The cylinder head. Here it is. Now, you might find this interesting with this model here. It used no head gasket. So what you did was use this, you can see he sprayed that stuff on there, copper coat. And for the seal, of course, to work, it's going to have a good finish. And it looks like he did a fly cut on a wrong foo mill. This is not going to seal a gasketless surface. Now, you run into gasketless surfaces on high pressure hydraulics. And I was a hydraulics guy, so it kind of helps in a situation like that. And most of you are not been exposed to that. So you can see the lines. I mean, I can grab it with my dirty fingernails because I'm always cleaning stuff. That it has a direct path through these scratches to fail. So this wouldn't have worked. It would have been one of the things that failed, like the transmission seal. So that needs to be redone. And let's see what else I was going to talk about. Other things look okay. He used the old valves, but they don't seem to be overly sunk in. And these may have had some modification done around the valve areas at some time. I don't know for sure. Just kind of get that feeling. You can see the advanced cooling for the head here. And that's extremely important, and why there's no head gasket is good heat transfer. And I'm going to come back in a minute with some words on heat transfer. Yeah, let's keep going. That's a pretty big country for a little dog, isn't it? What do you think, Charlie? You want to head over the ridge here? Okay, thanks for tuning in, folks. That is an interesting and important unit, and we'll get into that in a future episode. But next to it is really a nice gift from donation from a fellow. What it is some cup grinding wheels for the grinder, and these Norton SGs, I like them. They work fine. I know the super experts say Norton's no good, but I've never found that to be true. So thanks for that donation. It will get used. Okay, now we're going back. Now what happened is at the factory school and in the they weren't very good at it. Cylinder heads, in retrospective, they could get you going in a pretty good direction, but they weren't good at it. And especially on repair, But you got to figure the Harley Davidson company is keen on selling parts too. So other than, they showed how to make a drift to knock the valve guides out and stuff like that. And that's just really terrible, as I will show. And how to get valve seats out. And that was to take and grind a valve, take an old valve and just grind it down until it starts dropping down in, and then you weld it to the valve, then knock it out. And that's good. I modified that to just turning disc on the way that would drop down. And after getting the valve guides out, just coming through with a punch and tapping the valve seat out. So I'm going to talk about removing valve guides without causing further damage to the cylinder in this thing, but the cylinder head. Okay, let's look at it. So you got these valve guides, and I have one here. This is a test bench valve guide that I come up with, and has an O-ring on it. And it'll just slip in there, and I can test valves or a valve seat that I'm working on, or a port, and pull it out and continue working on the port, So it's just a test valve guide. But this will work as an example. I don't know if that'll stand there. But what you do is, I don't know if I can do this one hand. I think I can. Instead of like King Kong knocking these valve guides out with a hammer, this one here has a clip, circlip, and some of them have a shoulder, like old Sportsters and shovel heads. So I'd use 2 diameters of this gizmo here, and you can buy a piloted countersink, but this here's just a drill bit. I can't remember what size it is anyway. It's all worn off. So I put it in the tool and cutter grinder and circle ground this until it gets us back in the picture. The valve guide, like that, right? So when this valve guide is driven into the head or pressed into the head, it's going this direction, right? Under no circumstances, as a sharp millwright, as you all are, would know it's driven in that way. Then you put a drift in it, try to clean the carbon off of it and drive it out that way. And they're tight press fit too. And they've been hot and cold, and they're like fused in there. So what happens is you gall it. You'd be better off knocking it out the direction that it was knocked in, because when you reverse, you know what happens. It galls. Okay, you got the metal flowing this way on the surface of everything, and then you reverse it, and then it balls up. And that's just the way things are. So instead, And I'm going to hand this to my dad, who was a line chief for the Burma Bridge Busters in World War II, medium bomber squadron with B-25 aircraft with Wright engines, double bank, I think probably 14-cylinder engines, radials. And the components were aluminum. So what they would do on the aircraft engines is take these counterbores and go all the way through to where the port is, till it just enters the port here. You go that depth. You measure it, go that depth, right there. Then this port's still sticking out. Then this port here has 15 thousandths or less thickness on the walls, right? So you get an undersized drill bit, and you counterbore that thing almost clear through, just so it enters the port. Then you take a punch in there and knock it the rest of the way out. Now, if it has a shoulder, you'll need two of these. You'll need one that's bigger, and you drill it until the shoulder spins off, and then you take a smaller one that's smaller than this diameter by 30 thousandths and drill it on through, relieving that press fit. And then it just taps out. But you're not done. Okay, so what happens is the heating and the cooling, and this is air-cooled cylinders, air-cooled heads, and they get a lot hotter than automotive. They get just skyrocket hot. And it's best not to, and this is why new heads last longer than rebuilt heads unless you do this. So you knock the valve guide out, and then you have this blackened, not quite round hole. So whatever means you can, in the Pratt & Whitney rebuild kit, they had these spoon-shaped devices that were a clamp too, and you could put a little wrap of emery cloth, and then you rotate that through the head until you got bright metal. That's extremely important, because these valves, these valve guides and valves, particularly the exhaust ones, are getting just dangerously hot all the time. And if there's any oxidation between that valve guide and the cylinder head, you got a barrier for heat transfer. Then the heat concentrates in this valve guide, and oil starts burning in there, and it's so hot that it turns into crystalline carbon. And a couple of things can happen. Shovel heads, usually it just gets so rocket hot sometimes, and I can explain why. Is the valve guide can come loose, the valve can stick in it, and the valve guide can come loose, and then the valve guide and the valve are running your engine together like that, both moving. Or the valve can stick, and you just trash the top end of your engine, and that's real common. And that was happening a lot after 1979, in that era where they removed lead from gasoline. Okay, so it's critical. And it is on aircraft. There's no mistakes allowed in aircraft, and that's why they do this. And you should consider it with motorcycles because of the cost, okay? And, it might take you an hour to bore these things out of a couple of heads. But you saved so much, because if you knock them out like King Kong, you're going to have this burnt plus scored hole to knock a new valve guide in and just, and the head will last even less time. I hope I explained that right. Heat transfer, it's absolutely critical. Okay. So if you got that part licked, you're well on your way to doing a better cylinder head job. Okay, I'll be back in a second here. Yeah, back in the 70s and 80s, there wasn't the popularity. There's no Orange County choppers or any of that kind of stuff. There's none of it. And there was bumper stickers and stuff like that. It's like ride a Harley and go to prison. And there's just a lot of trouble with the motorcycle clubs and the police task force, I guess. And that was always a continual disaster. And the factory's attitude at the time was both sides were bad for business. And the Harley factory, there's a real division there too, cultural. You might find this kind of fun. I've always liked both the big twins and the sportsters. But these macho guys and stuff, or whoever go, oh, you got a little bike, the girl's bike, you got training wheels off that door, all this stupid stuff like that. And it's whatever, whatever makes people feel good, I guess. But at the factory, that was exactly the same situation. And it was, a different group of people. These people were a different culture that might be hard for me to explain because it was a different culture to me. Then there was a division inside this Harley Davidson culture between the little twin guys and the big twin guys. And I think there might have been some bitterness. And I'm guessing, don't take anything I say as, that's the way it is. It's just my observations, you know what I mean? I was just observing a situation that I was in. Okay, but you might find this kind of cool. Now, the Sportster guys on the Sportster end at that time, 1981, the factory did put more money into the Sportster line for improvements or whatever they thought they were doing. Well, I guess whatever. They were putting more money into the Sportsters in 1981 than they were into the big twins, or up to, okay? And I think there's a little bit of, I don't know, I just kind of felt that. And the Sportster guys were younger, the guys that handled that. At the factory, we had two sets of instructors, big twin instructors and little twin instructors. But the Sportster guys, it was nasty weather in 1981 in Milwaukee. Man, it's just so cold. I've never felt cold like that. It blows off those legs. It goes right through you. I'm not kidding you. And they put us in this isolated Holiday Inn away from Milwaukee so we wouldn't get in trouble. But back to it. The Sportster guys put, it was snow on the ground, deep. These, I think they were English or German made, kind of small sidecars on their Sportsters and drove around. They rode to work in the nastiest stuff I've ever seen. On their motorcycles with these sidecars, and none of the big twin guys did anything like that. That's kind of fun too. And I'll get back to my dad. It's kind of funny. Some of the best things that worked out for me, I learned from my dad, it was particularly on cylinder heads, because he had that aircraft experience up here. And I don't know if people know this, but here in Walla Walla, little tiny farm town, and I've got some videos I'll show around the countryside here. It's a mix of just, it's really quite stunning, this place I was just at. But there's this big patch of flat farmland. So when the war broke out or before, I don't know, but in the 40s there, they built this massive air base, and this was one of the spots where they did the B-17 training here. You know, they had this these long runways. And you might not know this, that they calculated how many bombs and bullets that they could get up in the air, and it took a long runway for those piston propeller bombers. It takes them a while to climb, and they loaded those old airplanes so much that they had to get rid of that stuff. They couldn't land with the stuff they took off with. It was too heavy. The plane would crush. So anyway, my dad was in the Burma Bridge Busters, and they were fighting through China to Burma to bomb the railroads there. And they were the furthest from supply. And they had to be innovative, and they had to fix their own engines. And you'll see, I put up a still photo of a B-25 with 650 caliber machine guns sticking out the front glass. That was one of their innovations. So what they used with that, they blow the ties out of railroad tracks, you know, ahead of a train. But what my dad, and he was the head mechanic, he was in charge, he was the civilian that would okay a flight. They had, I think it was, line chief was a wartime deal. And my dad trained up here. He came from Alabama and trained up here. My mother was a secretary, and they married, and that's how I got here anyway. So a lot of the stuff they had to do there, they had to make sure the engines would run properly to pull that stuff, all that armament and all that stuff up in the air. And they worked as a team, and my dad knew just everything about everything on that. But I tell you, the one thing he hated to do was fly on those things. He did not like flying in any aircraft. And then he crashed a motorcycle over there in India, and he didn't like riding them. He liked motorcycles, but he didn't like riding them. He liked airplanes, but he didn't like flying on them. So, but what they had to do, they had to hot rod those engines sometimes, and they did a lot of unauthorized stuff. And so I learned a lot from my dad on air-cooled engines. But they had to preserve that stuff. Aircraft stuff's more expensive, of course. So that's why they did all that non-destructive things. And I'll point out that on those aircraft engines, they're cast aluminum in the head, and usually they're one piece, or the head was actually screwed on. You know, they had to eliminate a head gasket failure, and that's how they did that. So they had these innovative toolkit to remove the valve guides or install the valve guides. You machined them out, and then you cleaned the hole, like I was hone the hole, and then push a new valve guide in, and they had tools that did that. They had another tool that could remove the valve seat and put another one back in. Okay, I will be back. What do you think? Okay, let's keep going.